So whatever we seen in the last video is that, so transformer consists of, let me say, the transformer majorly contains two things. One is the coil and another is the core. Coil and core assembly putting together, this we call as coil and core assembly. So coil and core assembly constitute the transformer. Now if we see what are the functions of each of these elements, that is coil and core. So let me take one by one. That core, usually based on the construction of the core, we have two category. One is the means transformer are of two types. One is the core type transformer. Another is shell type transformer. Let us say shell type transformer based on the nature of the core. So here just let me put the generalized idea that for core type of transformer, what we do is that first you take some structure just like a rectangle in shape. So this is some iron or any magnetic material which is cut into this shape like a rectangle shape. Now on top of this material, this what we call as a core basically. Which one? This gray color item is referred as core. And now on top of this core, what I will do is that I will place a coil in this way. A coil is placed in this manner and it is extended out. This is, let us say, one dash coil. And we may have more than one coil also, as like this. On the other side of the same core, so we may put one more coil. So this may be two dash coil. Two dash coil. Now see the phenomena, the fundamental difference first, then I will go to the core coil assembly etc. concept. And let me take other type is the shell. Here itself let me show the difference, then you will get a better understanding. So in case of shell type, what I will do is that, so as like this. So let me take a big rectangle shape and inside which I'll take two small rectangles, as like this, and one more rectangle as like this, and see that I'll place a coil over here. A coil is placed on the center segment of this core as like this. This is a coil. And we may have put more than one coil also. So for example, if I am putting second coil somewhere here, and we can put more number of turns also as like this. There may be overlapping between two coils also. Now see the clear difference between these core type and shell type transformers. First thing is that in the shell type transformer, the coil is protected inside this shell. Just like everything is inside. See, all the coils or conductors are enclosed by the core. Let me write that point. Coils are enclosed by core structure. Where in shell type, generally in shells everything is inside, it is protected by that shell itself. That is what the shell type. Another is core type, so in which see that the coil is external and core is inside, or you can say coils or right, or core is enclosed by the coil. Core is enclosed by the coil. Means coil is outside, core is inside. Here, whereas coil is completely enclosed. That difference you should understand. I don't know whether this enclosed term giving proper meaning here or not, but you should be understand carefully that. So here coils are outside, whereas here coils are completely enclosed by the core in all sides. Okay, so that is one thing. And just try to see whatever may be the nature of the core, what phenomena going to take place, and what is the importance of this core over here. That let us understand first. What happens is that when we don't have core, the flux established by the coil used to disperse in the air as like this. The flux established by the coil used to disperse in the air as like this. But if flux is dispersing in this way, see the flux which is spreading it other side of the coil 2 dash is not linking with the coil 2 dash. Means this is wastage of the things. So in order to use effectively the total flux, what are we doing is that we are using the core. Now what happens is that whenever some current is passing through this, the flux which is produced by these coils will definitely, all flux lines will confine within this core itself. It will not move to the outside of this core as like this. All the flux lines just confined to the core. Then these core will act as a path for the flow of flux lines as like this. Then it will try to come back and meet over here. So all flux lines are flowing through the core and nowhere it is going out of this core path, so that the flux lines which are produced inside this coil 1 dash is associated with the coil 2 dash. This is what effective flux linkage. Means there is no wastage at all. Total flux which is produced here is linking with the coil 2 dash, so that more induced EMF can be developed, so more amount of the current can be produced by this coil. That is what the effective way of making the power transfer. So what is the function of core? Core will try to confine the flux inside the core which is produced by the coil. That is one thing. What is the function of coil? Coil will produce the flux. Let me write here those 2 points. Coil function is producing the flux. Producing flux. Let me say flux as phi. The produced flux will confine to the core. The produced flux confined to the core by using this magnetic material. Core is usually any magnetic material confined to the core. If we don't use the core, what happens? The flux lines will disperse as like this. So effective linkage does not take place. So if flux does not link with the coil 2 dash in a large amount, then you cannot expect more amount of the induced EMF. If more amount of the induced EMF is not developed, then total power which we gave to the coil is not going to be transferred to the other side, coil 2 dash. So in order to get more amount of the flux linkage with the coil 2 dash, we are using the core, and this coil flux is linking with the coil 2, so thereby effective power transfer can take place. Okay, right. So now let me see one more video, animated video, to get a better understanding of these things.